Today's theme is, What is Natural Radiation, Volume 1. Let's get started.
Daichi, a walk in the park feels good, doesn't it?
Right, but while we are walking like this, we are impacted by radiation around us. Do you remember?
Yes, I do. However, radiation is invisible, so it's hard to imagine what it's like.
I can understand how you feel it. Then, today I would like to talk about natural radiation, which on a regular basis makes impact on us.
Okay, Daichi, how much impact is usually made on us by surrounding radiation?
This was explained in the previous video, but according to the latest data, dose to one Japanese person per year is around 0.31 millisievert deriving from radiation, which comes from outer space, around 0.33 millisievert from the Earth, around 0.47 millisievert from aspiration of radon and thoron, around 0.99 millisievert from food, and around 2.6 millisievert from medical care.
Now I understand the dose on Japanese people caused by natural radiation. By the way, how much impact is made on people around the world on average?
This was also explained in another video, but according to the latest data, dose on people in the world, annually and on average, is around 0.39 millisievert deriving from radiation, which comes from outer space, around 0.48 millisievert from the Earth, around 1.26 millisievert from aspiration of radon and thoron, around 0.29 millisievert from food, and around 0.6 millisievert from medical care.
Well, compared with Japanese people, dose and its breakdown are quite different, aren't they?
Right. First of all, one of the reasons for much medical exposure on Japanese people could be, for example, that many Japanese people take CT scan and other medical examinations. For the next, one of the reasons for much exposure from food could be, for example, that Japanese people consume seafoods more than people in other countries, and are more affected by that. And one of the reasons for less impact caused by radon and thoron in Japan could be, although it will be also covered in another video, for example, that the concentration of uranium-238 in the Earth is relatively low, and that Japan's houses are generally well ventilated. The remaining factors of the impact caused by radiation coming from outer space and the Earth don't show significant differences between Japan and other countries, but regarding the radiation from the Earth, there are considerable regional differences, therefore that will be explained later. Now I will explain the impacts caused by natural radiation in sequence, other than the impact caused by medical exposure. First of all, I will talk about radiation coming from outer space, down to the Earth. As explained in another video, radiation, called cosmic ray, is always coming down to the Earth from outer space. Specifically, you can have an image, for example, that protons with high energy coming from outer space react with oxygen molecules in the air, and that produce new radiation like gamma rays, which reach down to the Earth, as a result of chain reactions.
Now I understand that radiation is coming from outer space, but why is radiation also coming from the Earth?
Good question, Hikari. To put it simply, when the Earth was created, around 4.6 billion years ago, radioactive materials were included from the beginning in the materials which made up the Earth. Of these radioactive materials, those which exist in the areas close to the surface of the Earth, specifically, including uranium, thorium, as well as radium, which are produced as a result of their physical decays, are making impact on us on a regular basis. In the world, there are regions where dose caused by natural radiation is much higher than the average dose of Japanese people of around 0.33 millisievert per year, and the average dose of people in the world of around 0.48 millisievert per year. For example, in the region named Yangjiang, in China, it has become apparent that dose on people is around 2.3 millisievert per year. As another example, in the region named Orvieto, In Italy, it was reported that dose on people is around 3.4 millisievert per year. In the region named Ramsar, in Iran, dose on people is slightly higher than the previous examples, and it is reported that it is around 4.7 millisievert per year. Moreover, in the region named Kerala, in India, dose on people is almost double of that in Ramsar, and it has become apparent that it is around 9.2 millisievert per year. This is the last example, and it is reported that dose on people in Araxa, in Brazil, is more than double of that of the previous example of Kerala, and it is around 19.6 millisievert per year.
Well, if they are exposed to so much radiation every year, I think that it might cause negative impacts on their health, but what is actually happening?
In fact, so far no significant increase of cancer incidence rates and mortality rates have been observed, even in such areas with high natural radiation level. As a result of researches on risk of developing cancer caused by exposure to natural radiation, even if total dose on people is the same. When comparing the so-called acute exposure, in which people are exposed to a large amount of radiation at once, like the victims of atomic bombs in Hiroshima and Nagasaki, with the chronic dose, in which people are exposed to radiation on a daily basis, like people living in the areas with high natural radiation level, impact on the latter is less than that of the former. It has also become apparent that impact of the latter doesn't show difference with people in the areas with not so high natural radiation level, and this fact has been confirmed by experiments using mice.
Impact seems to be totally different, which appears on human body when people are exposed to radiation at once, than when people are exposed gradually.
Correct. This time I talked about dose, which drives from natural radiation, and of the natural radiation, specifically I explained radiation that comes from outer space and the Earth. Next time, I would like to talk about in detail the remaining exposure, deriving from breathing and diet. Let me wrap up my lecture by providing you with the key points. Today, first I talked about dose, caused by natural radiation. The dose is around 2.1 millisievert per year in Japan, and around 2.4 millisievert per year in the world. Of the dose caused by radiation, coming from outer space is around 0.31 millisievert per year in Japan, and around 0.39 millisievert per year in the world. I elaborated that the radiation is generated through reaction between protons coming from outer space and molecules in the air. For the next, dose caused by radiation emitted from the Earth is around 0.33 millisievert per year in Japan, and around 0.48 millisievert per year in the world. I elaborated that this is due to radiation emitted from radioactive materials, included when the Earth was created. At last, I explained that there are areas with high natural radiation level in the world, but no significant increase of cancer incidence rates and mortality rates have been observed in the areas. Okay, that's all for today. See you in the next video.